Hey everyone.
Hey, hey Jen.
How's it going?
Oh,
Sounds
sweet.
good.
Oh,
How is everyone doing this week?
probably pretty good.
Fantastic.
Yeah. Oh, wait, where's my mute button? There it is.
Sweet, 7 o'clock. So, shall we get started?
I think so, yeah, because we're recording it and anyone can catch up using that.
Sounds good. Hello everyone. My name is Jenifer Champagne, and I work at Weever Apps. I'm going to try to help, I guess, walk through a few of the things that kind of go through my thought process when I'm trying to plan out what programming languages, tools, things like that go into a project I'm going to work on. And hopefully everyone will find it useful. At any point, feel free to interrupt me, even at work. That's always kind of a disclaimer that I throw out there where I'm not really trying to give a formal presentation or be a total authority on anything. If at any time someone has questions or anything like that, feel free to throw it out there. So, I think the other day I had posted a question of what programming languages people were familiar with. And there was a decent variety. I did see, I think it leaned a little heavy towards Java, maybe C#, and I feel like there was another one, maybe just JavaScript. But one of the things I kind of wanted to bring up too is that, it's very important that one of the considerations is that I guess your comfort level in the programming language or the tools that you're going to use, because I know we have, it looks like, around a dozen people on the call or so. And so I'm not sure exactly how many we're planning to have in total on the project. But there's one of those considerations that's kind of a first step is, what is the timeline that we're thinking about for this project? So, for example, if this was a project where, oh, we need this done within a month or two, then I'm probably going to pick tools and languages that I'm very familiar with because I need to hit the ground running, versus, oh, this is an 8 to 12 month project. And so then it doesn't overly matter what it is because I can learn along the way. I think this project is 3 to 4 months-ish. Is that correct?
It's a little tighter than that. We're gonna try to start coding early July, and then we'll wrap it up by end of August. However, I think what we'll try and do is say, hey, this is sort of like the core of what we want to build, and we'll try and have that built sort of by the end of August. I think we're going to try and hopefully deploy it before then, so we can see whatever we're building live as we make it. And then if there's anything left, as there probably will be, people will be welcome to continue contributing to it after August.
Awesome. That makes sense. So definitely on the tighter side of deadline. That's good to know. So kind of a first step before we really talk about what language we're comfortable with, I guess going through kind of a few of the points that are from the requirements workshop would be prudent to do. So just feel free to correct me. Like, I kind of know what the project is doing, but I'm also asking questions to make sure that we're all on the same page and we're thinking about it correctly. But is this looking like it's going to be a web application or more like an application that runs on a desktop computer or maybe even a mobile? Mhm. I guess that brings up another question where I guess, has there been a decision of which platform that you're going to make stuff for?
No, there hasn't. We're going to be discussing that next week. So next week, we'll be sort of meeting up to really determine really nail down the requirements, like that sort of outcome that we want to address and focus on, or the core set of outcomes that we want to sort of answer, and then discuss approaches that we want to take to address them, and then that will sort of help clarify how we want to build it. So I think tonight it'll be good to learn more about what our options might be. So if we decided we want to make a desktop application, how do we what languages might be good for that? Or if we wanted to build a web application, what are our options there?
Totally. That is good to know, because one of the notes that I was noticing within that from that requirements document was how the it's I'll just read it out. It says, "Don't forget that they need it to work offline," which is, of course, its own extra bundle of complexity when you're going to be working with a web application. Not to say it's necessarily a massive amount of complexity, but that kind of enters into that decision. You need to think of all of those little requirements, especially when it comes to something that's super important that if it gets missed early on, you could potentially make an entirely invalid product at the end. So it needing to be online is kind of, or offline is something good to kind of keep in mind where um, one option, so let's just talk about the web path. When we are thinking of building and deploying a web application, we know that more than likely we're going to need to be hosting and maintaining some sort of service layer. Even if that just means that the application gets deployed to something like Netlify or AWS or what's the just escape me. Yep, Azure is one of them. Exactly. So there's like a lot of places we could do. At the same time, it could be as something as simple as an FTP account where there's a HTTP hosting behind it. So it's important to keep in mind that it's something that we're going to need to maintain and always have that deliverability. So on the other hand, if we're building a desktop application, then the requirement ends up being that, well, now we don't really necessarily have a cross-platform way of building a UI, whereas, web application, we're thinking HTML is our structure, CSS is going to make it look good, and JavaScript for extra interactability. The nice thing about it being in a web application is that that gives us that freedom to make one UI that works. Now, at the same time, see, we're here to talk about programming languages, but programming languages won't even come into play for a little. So at the same time, if we're thinking about, well, maybe we want that power of building a web application, but we still want things to run on the end client's computer. We still want it to deploy or be more like a standalone application we don't need to maintain. And that's kind of where some tools like Electron, which I know there was some discussion of building Electron apps in the channel. That's something that could come into play where it is effectively a tiny stripped down Chrome browser based on the Chromium project that then kind of can be bundled, sent off, and you know that it's going to be cross-platform again. So we've kind of got a few options, but then when it comes to making a proper desktop application, usually we're not thinking of backend services or stuff like that. It certainly can communicate to some web server somewhere off if we want to collect information. But the thing to keep in mind then is, again, what are our platforms? What are our target use cases? Now, I know, Rodney, you kind of mentioned that some of that decision making is going to happen next week, but just kind of a bit of early discussion. Like, do you or anyone here think that there's a chance this would be running on something that's not a Windows computer? There we go. Good to know. So that yet again introduces a little bit more fun complexity. So a lot of the time when we're starting to think of these tools we want to make, I usually start off with trying to be as familiar with as possible with the end product that we want to build. So we already know it needs to work offline. We know we're going to make some games. We don't necessarily know which platform it's going to be or which, really which anything it's going to be exactly yet. So hopefully we can cover all kinds of different bases about like tools and stuff. That makes sense. But I want everyone to kind of keep that in mind going into that session when you're making those decisions. Kind of come back to what is the expertise level of the people that are going to be working on it, given that there's a tight timeline. What can work in an offline way conveniently? Because the other thing is, a lot of the time you'll encounter a tool like Electron, for example, and it'll give you a nice rosy message of saying, well, you know, if you use Electron, you can package a bunch of HTML, JavaScript, CSS all together, deploy it, no problem. It's a cross-platform application. But nothing actually works that well. I think all of us here, regardless of the amount of programming experience we may have, probably at this point realize that pretty much all software sucks to some extent. So what you end up needing to do is decide what are those features that are absolutely critical and which are the features that's okay to have bugs in. There's always this give and take that you're going to do. So try to keep those top priorities really strongly in mind. So there's a lot of that out of the way. To talk about programming languages, the one thing that I kind of want to start off and make super duper clear is that at the end of the day, you can do virtually anything with any programming. And that's kind of why I focus on the specs and I focus on where our skills are at. And the other thing I usually focus on is what tools we're going to need to work with or that we want to work with. So Rust is a language that I use a lot. And just to be clear, I'm not recommending that as a language for the project because there'd be a lot of learning involved. And I highly doubt you'd be able to make the timeline for that. But one of the things that I like about Rust is that it has a unit testing system built in, a static analyzer built in. It has a lot of nice features that once you get comfortable with and you learn how to work with, you realize that it's able to take a lot of your work off your plate. So I guess another question that kind of comes up is, do we think that this project is going to be something that, you know, we build, we deploy, we learn some lessons from, and then we move on to the next project? Or is it more of a project that we want to build it, we want to be proud of it, we want to maintain it long term? Do we have any thoughts on that yet? Maybe not.
Yeah, it's really hard to say at this point. I think it depends on how the finished product or whatever we end up building in the summer takes form, you know? If it's something that's like, you know, is really successful, then I think it could be something that we, you know, will look to maintain. But I think what we'll end up being able to build is more of that really prototype MVP, you know, we want something to be able to put in front of people.
Oh,
But
just
in a
one.
couple,
You know,
Sorry,
it'd be
just
pretty
one
cool.
quick question. What does the successful mean in here?
I don't know.
sorry,
What was that?
yeah, I didn't catch that.
You said that we are going to keep developing it. That if it is successful, but I honestly thought that our idea was Jen's second option, which is build something we can product and gonna maintain it. So I'm just to be clear.
Yeah, I think that would be the ideal route, right? That the ideal outcome is we
Yeah,
build
that's
something that, you know, we're really proud of. But at the same time, I don't think there's any shame in building something and then, oh, you know, this doesn't work. And then you know, moving on from that, you know, and trying a different approach next time, you know?
Yeah, fair enough. Yeah, great.
It'd be pretty cool if like we were to have it as something that we can maintain, and then like each new student that we have coming into the college, and then eventually they join, the developers can help with like a new game that could be added on to it. So something that could, you know, actually be pretty cool for like newcomers and new students to, like learn code and stuff.
Definitely. I do think there's a lot of value in going that direction, and I don't want to influence how that direction ends up going. So whether it was, I think, the next session when those decisions are made, it's just something to kind of keep in mind because to give a bit of an example, if I know that something needs to be maintained and live long, then I'm going to start to prioritize some things like unit tests, integration tests, and end-to-end tests, and kind of the making sure that I have the right set of each of those. And I'm probably also going to want to have documentation. And the most important thing you can do is allow your code to generate as much documentation as possible. So, you know, Rust may have that built in. I think for Java, there's Java docs. I mean, everything kind of has its own kind of documentation framework you can pick from. Not all of them are integrated right from the start, but you want documentation, you want testing, and you also want a very clear set of instructions for deployment. Because even when a change happens, it needs to be simple enough so that that can get deployed. One of the things I've seen in an open source project that I came across recently was the author was really happy about accepting PRs, that people were contributing, and some people were actually getting frustrated that even though their PRs were, that a new version was not being released. So people had to hack around trying to not use the official version, but use the PRs they submitted. The reason for that was that that repository author had a really complicated process for building the application and deploying it so that it could be this released version. People just go and download an executable file. So super important to think about kind of what are the things that are going to exist around your project, but from the developer point of view. Because obviously, and this kind of goes back to that short-term, long-term kind of lifespan of your product, is that if I have lots of documentation, I have lots of testing, I have lots of all these extra things that doesn't add even a single ounce of value to the client. It kind of indirectly does in the sense that more features can be added down the road, pretty straightforward, versus being this huge effort that maybe nobody wants to take on. But generally, it kind of falls down to that. So keep that in mind when you're trying to decide on testing. So we are, and I'm just going to keep kind of reiterating it just to make sure it kind of sticks in our minds. We need to be aware of what specs that are absolutely super important. We need to think of how our users are going to be using this, what platforms they're going to be on, what kind of operating systems, what kind of physical hardware, that sort of thing. And we need to know what kind of tooling we want to use. Obviously, I highly recommend at the very least having integration tests. I find integration tests are kind of the easiest to do And I don't know if we actually have a test framework kind of, or the different types of tests. I don't know if we have some kind of workshop planned out for that already. But if we don't, I can always come back to kind of walk through those different things.
Yeah, that may be something that we can schedule in July sometime.
Awesome. So yeah, like you'll at least want some testing, and you may want some documentation or different things. It kind of, your mileage may vary. But now the nitty gritty of the languages. And also, I will apologize in the middle of this. I have a tendency to ramble. So hopefully this is all sounding useful and making sense. But talking about the language itself, so if I'm going to be making an application, ignoring web development for a moment, C, C++, what have we got? C, C++, C Sharp, there's Java, there's all kinds of different languages. But I guess the question we have to start to think of is there a language that's fairly universal across the program at Mohawk that we think most people would have at least some exposure to? Or is there something at least that we do all kind of feel confident about? I think the three languages I saw the most in the chat, like I said, was Java, C Sharp, and JavaScript, if I'm remembering. But yeah, I guess there is that question of who will own the code. So we have a whole club full of people who will be participating. But let's just say, for sake of argument, everyone who's interested in this project lost interest. They ended up not being interested. And we're down to some core group of people that are super dedicated and definitely going to stick around. What language do those people feel comfortable with? Because we need to make sure that we've got mentorship. And, myself and some other people from Weever, we will definitely be around and helping for some of that mentorship. But we need to make sure that everyone is kind of comfortable and everyone has has someone they can go to for help. Because we're all at different levels. Some of us have a lot of experience, some of us don't have as much experience. But we always want to kind of make sure that it's clear where we can find help. So I guess, yeah, kind of throwing the question out there, are there any languages that are kind of the most explored or the most understood in that program?
I think probably C Sharp and JavaScript.
Yeah.
Java right now.
Because you just kind of touch on Java in like second and fourth.
Mhm.
But I think there's more C Sharp over the course of the program and JavaScript.
I've only been
Oh, sorry, go
sorry,
ahead.
Jen. So I'm only been exposed to HTML, CSS, some JS and PHP.
Cool. So that almost does make it sound like, if the smaller amount of, what's the right word? In the short term at Mohawk, if you're starting off with web development and stuff like that, something like the Electron application probably is the way to go. But either way, I'm still seeing those same three languages kind of predominantly. Because we've got the HTML, CSS, JavaScript insofar as front end. If it's any kind of a web application, we'll definitely have those. And then there's the other side of it where there's some experience with Java and C Sharp. So with that, oh, go ahead. Yep. I agree. It does seem to be leaning that way. Again, I don't want to press down on the scale one way or the other of that decision, but it does sound like that may end up being a solid choice to make sure that everyone is kind of able to do something and contribute. But so let's just think about that for a moment. So regardless of what we're going to build, actually, I guess it is still good to kind of break it down into those two things. If we're just building a plain old application, we're going to use some sort of graphical user interface library, then both C# and Java have a lot of options with those. So one of the things I would probably be keeping in mind if I'm thinking of those two languages is that, for one, Java is a totally cross-platform language. It's not a language I've used in a while, but it is a very widely used language. So you are probably going to be able to find help with it. You're probably going to find plenty of libraries of what you need. Obviously, you're going to need either a graphics library or an HTTP library to some extent if we're going to build this web application. But Java is potentially known for a bit of slowness as well. So it's worth being aware that it's not going to be the fastest option. More often than not, that probably doesn't matter, but it's something to be aware of. So C#, on the other hand, is still a language with a runtime, and so it's not as heavy on the kind of processing that happens magically in the background as Java. But you do get an executable out of it, so you get this binary application that you can compile and release. And so the thing to keep in mind with that is that not all platforms support C#, because like with Java, Java requires a Java runtime to be installed on that application, on the operating system. C# similarly requires the .NET framework to be installed. There is the Mono framework, I think it's called, which kind of gives you like Linux support and a few other platforms for having that .NET alternative to cross-compile C#. But again, both of those decisions are going to come in mind when you start to think about specifically what platforms are we going to support. Are we going to support Windows only? Then by all means, C# is probably your best bet. If you decide that, oh no, we definitely also want to support Macintosh, for example, then you'll have to start doing some kind of a comparison. Maybe a short investigation on what your options are. Should it look like Java or should it look like C#? It'll depend on how good the support is for those. So going back to JavaScript, got mentioned a bunch of times. So one of the options that could happen is that maybe you build the backend portion of some sort of a web application in either C# or Java. So what it ends up doing is it ends up acting like a backend API. It'll do your calculations, it'll do your processing, it'll do whatever kind of pre-rendering it needs to do, or talking to maybe some small database, whether that's an in-memory database or that's some centralized server. But what you can end up doing is using one of those two languages as your backend, and then using something like Node.js or Electron, or, sorry, I didn't mean to say Node.js yet. Electron or something like that, where you're building your front end in HTML, CSS, JavaScript, and then it's communicating to whatever backend you've built. The default, more or less, I believe, of Electron applications tends to be Node.js, which is kind of your Java equivalent, except written in JavaScript. And so that's probably going to be another attractive option, where now anyone who is familiar with JavaScript is able to do work both on the back end and on the front end. That's a big part of why at Weever Apps, for a really long time, we were completely a JavaScript company. It started off as being, JavaScript in the front end, PHP in the back end, kind of like you might typically see. Eventually, the PHP backend was replaced with a Node.js backend, and the whole company was a JavaScript company. we've kind of moved on from then. But that was a very viable option that really helped us grow, and we were able to build complex applications pretty easily. Node.js has a very nice wide variety of easily installed external libraries. So that may also come into play. Then finally, if we're thinking purely that this is just a web application, maybe it's going to use a framework like Vue.js or Angular or React or Svelte. There's still lots of options in that regard where maybe we want to use a framework like that, or maybe we just want to make a plain old-fashioned HTML, CSS, JavaScript application. This project, I think it was for making games. Is that right?
Yep.
Cool. So then, if we're thinking about these few sets of languages, then again, similar sort of thing starts to come up. Where if we're using, let's see, if we're using C# or Java, there's probably some sort of drawing library that would allow us to draw just lines. Or maybe you want to use a web canvas element in a web page. So then again, we're back to we can do everything purely in JavaScript, purely in HTML and CSS. The HTML and CSS ends up really just being the container for your games, not really needing to do anything special. And then you get to write entirely JavaScript code. One of the bigger, or a few of the bigger libraries for just using JavaScript to render on the page is something like 3JS and a library I can't remember offhand. When I think about it, I'll post it in the channel. But so now what we were able to do is basically all of our code can exist in a JavaScript file, or it can exist directly in the HTML file itself if we wanted to. Even if we were using some tools to take a whole project folder and transpile it down to as little JavaScript as possible, we could still potentially deploy a single HTML file with JavaScript embedded into it that then anyone can double click, it'll open in a web browser, and it would fully work. So you can kind of see, like, regardless of which language you pick, there are options. And they all kind of have pros and cons, but it's one of those unfortunate things that the cons won't necessarily be obvious in the early stages until you've kind of been burned by them. At least that's generally been my experience, where something looks really great. Oh, this new technology, this Redis database, this whatever queuing system, I'm going to use that cool thing because all these people have said it's great and it's this exciting new technology that should solve my problem. And then you build it out, and then it turns out it does solve your problem, but it gives you 2 new problems. Unfortunately, that's just the reality of it. So all of these things kind of need to be considered and weighed. But at the end of the day, I want it to be very clear that or at least I hope I was clear in conveying that no matter which language gets picked or which tooling gets picked, there are a lot of things that we should keep in mind, but no matter what, there's going to be a way to solve. So if C# gets chosen, if Java gets chosen, heck, even if Rust got chosen, because all of you really wanted to have a rough time, no matter what, in the end, you'd still be able to finish off this application. Whether or not it ends up being exactly the vision you had in mind, the most important thing is those specifications. What are those actual requirements? And how do we make sure we achieve those? So I probably talked for a while. I'm curious what people's thoughts are, or if they have any particular questions, if they have any thoughts about what they want to do. Now's a great time for me to help guide in any way I can.
Yeah, I can kick things off. Back when I was in school, I was part of a hackathon where I built this like a little demo app over a weekend, and I came across what they're calling progressive web apps, a
Mhm.
PWA, and I found that that was like a really easy way to make uh, like a JavaScript client-side application available offline. I don't know
Mhm.
exactly how it works. A little bit of background for people who may not be familiar with this. So, I believe you can do this with almost any website, but with a lot of like those, like the modern JavaScript frameworks like Vue and React, with the one that I built in Vue, I was able to say when I was creating it in the CLI, the command line interface, that I wanted it to be a PWA, and then it just added it in. And what that resulted in was when you viewed my little sort of application in a web browser, you got a prompt to say, hey, do you want to, like on your phone, you got a prompt to say, hey, do you want to make this available like on your phone? And then if you click yes, it would show up like an app on your phone. Um, and it was really cool because it kind of provides a lot of like, I think, offline functionality. Jen, I was wondering if you had any experience working with this. Like, is it something that, is maybe has a lot of gotchas that I didn't run into because I was just building like a toy app, or is it something that might be a valid option for us?
Absolutely. I do think it would be a valid option and something to keep in mind. Weaver's primary two applications actually are both progressive web apps. So the kind of thing that you get by building out a progressive web app, and just like you said, whether it's Vue or React, there's a number of frameworks out there that would let you build that kind of application. So what it ends up being is that you you know, create out your application and whatever kind of coding you're going to do. If it's Vue, you're making .vue files. If it's React, you're making like bits of JSX files where you've got HTML and JavaScript all mixed together. And then you're going to use some kind of command line tool, just like you mentioned, to kind of transpile that. And so what it's going to do is it's going to convert those fancy JavaScript frameworks. It's going to convert the code that you yourself has written into plain old HTML, CSS, and JavaScript. It'll usually minify all of that content too so that it gets squished down. But now those are your sets of files that are really all you need to run the application. So when you go to load that page, what ends up happening is it loads all the JavaScript, it loads everything in, and then you're presented with a page where when you're clicking links, in a normal web page, a link would probably take you to a totally different page. You'd have a bit of a page load. But a progressive web app, what it's going to do instead is it's going to override what happens when you click links, push buttons, etc. So that the end result ends up being that you never actually go to a different page. So you might be clicking through links and opening dialogues and saving forms and doing all kinds of stuff, but you've never actually left that one page. And that's why it kind of acts very similarly to when we're bundling something in like an Electron app or something like that. That gives us the smallest set of files we need to run the entire application. And just like you mentioned, at that point, you can totally use it offline, so long as you're not relying on some kind of online API. Because, for example, if you were going to use something like, say, Firebase, that gives you user authentication and minimal database support, but it's a third-party service up in the cloud, then obviously you need internet connection to connect to it. So you'd want to make sure that you're not relying on any external dependencies if you're going to use a PWA. Now, Jen had a question in the chat about transpiling. I've mentioned that a couple times. So probably most of you are familiar with compiling, where we're taking code and we're turning it into a machine language binary file. It's a file that we can no longer edit or really read, but if we give it to a computer, then it's able to execute that. So as opposed to compiling, transpiling is converting our code into other code. So it's not the final binary that you'd actually be able to use to run the application, but it ends up being a new form of the code that then some other application can read. And so going back to the progressive web app example, when we have a bunch of our JavaScript that's, whether it's Vue files, React files, whatever you want to call it, we've got all of this complex stuff. Maybe we're using modern JavaScript, which technically isn't supported in old browsers. We've got all kinds of fancy stuff. So then if we say we want it to be compatible with Internet Explorer 11, or we want it to be compatible with Safari browser, or whatever it might be, and we know that whatever version it is we're targeting, oh, well, it doesn't have this modern CSS, or it doesn't have this modern thing, et cetera, et cetera. So what we're doing is we're compiling from something that's modern, or something that we can easily work with, into vanilla JavaScript that's compatible with ancient browsers, that then that's what we can use to release. It means that the end user who's loading it doesn't need to have a modern browser, doesn't need to have modern whatever, it'll work. And so the most common tooling you'll probably find for that with JavaScript is Babel. There's another one that's better than Babel, but I can't remember the name of it offhand, so I can also post that in the chat. But Babel is this Node.js application that can take any kind of modern JavaScript and convert it into other JavaScript that then any browser can understand. So any other questions? Circling back, I do think a progressive web app would probably be a good idea.
Can I ask if it does go the route of web application, is there much cost associated with hosting it?
Well, that will depend on we mentioned those external dependencies. And so if your application, for example, ends up being just HTML, CSS, JavaScript, it's only running in the user's browser and there's nothing else we need, then really you can find the absolute most basic hosting possible. And there are plenty of free options. So for example, Netlify is one of those quote unquote serverless hosting packages. They have a free tier that would probably be plenty for that kind of application. But then let's just say you want to be tracking user data. So then the question is, how are you going to collect that data and where are you going to store that data? So if we needed some statistics, maybe I would want to send it to a third-party service, which then complicates the need for being offline because now we have to have some kind of way of like storing that until internet connectivity comes about, if it ever comes about. But otherwise, let me see. I apologize. I totally lost my train of thought. Could you repeat the question?
Oh, I was just asking what costs might be associated with it, but it seems like make it simple and it won't cost much.
That is true, yes. And so the only other thing I was going to mention too was like maybe you want to be storing that yourself, and so then or say you wanted user authentication because you wanted some kind of login system, then you need a database somewhere, and that's when you start to look at kind of more traditional hosting packages. I would not necessarily recommend going deep into cloud services unless you're getting a good deal. So, maybe you're getting free package or something like that. I know AWS has a free tier for some very minor stuff. But at the end of the day, anytime you're learning a cloud, you're really only learning their platform and you're not really learning necessarily how it really works or how things are really hosted. So I kind of recommend not diving into a cloud service unless it actually makes sense to. But yes, as long as you build it simple enough, then cost shouldn't be a problem. Anyone else have any questions or curiosities?
Yeah, I have a bunch of questions actually. Would you recommend using, like, let's say we chose JavaScript. Would you recommend using a framework like Vue or React versus just vanilla JavaScript?
I think it depends on what you're going to make, because I know I've heard that the intention is to make games, but there's kind of two ways you can go about that. I briefly mentioned the canvas element where you can do actual, just plain old drawing, where I say, oh, I want a line there, I want a circle there, I want to show some picture here. If you're going to do something like that where you are using code to draw, then it doesn't make sense to use one of those frameworks, because really that framework ends up just being a thing that's supporting up the canvas and nothing else. On the flip side, maybe you want it to be a more traditional website. So, you know, the way that users interact with the game is actually drop downs, buttons, text input fields, any of those kind of form fields that you would traditionally see in a website. So if you're making something like that, then I would 100% absolutely recommend you use one of these frameworks, because you can start to write your code in a way that's a little more sustainable. Because like taking Vue, for example, really all the frameworks are kind of the same. They just have their own flavor. But in Vue, I could make a component file that actually takes some inputs and then will render something on the screen. And when you think about it, that's a lot like when we're making functions in a programming language like JavaScript, C#, any of them. You get to make these small isolated blocks that are easy to read, easy to understand how they're used, and fairly easy to even look up where they're used. So if you go with some kind of HTML-based game, then highly recommend it.
Cool, thanks. I also had another question about if there is a steep learning curve with like using graphical libraries. So like let's say we decide we want to build a game and it has a UI that we want to be maybe interactive and stuff or look good. I've never personally used any sort of thing like that, like 3JS or anything for Java or .NET. Like, are they hard to kind of get up to speed on and learn and work with? Also, like, do you need to know like a lot of math and stuff for that?
It can depend on how complex you get with it. So for example, if you're going to use something like 3JS or other frameworks like it, what they'll usually provide you is some sort of API for you to say, oh, draw this shape here, show this image there. You'll have a command that basically will run 20 to 60 times a second, and that's kind of your frame rate, where every time it runs, it's going to redraw the screen. So when you use something like this, at the end of the day, really all you're doing is you're telling the screen what to draw, and you're doing that really fast many times per second. So if, for example, a half a second has passed and I know that a ball on the screen needs to travel however many pixels, like 20 pixels in that half a second, then that's where your calculations of where to draw it are influenced by that value. But just like you said, yes, actually, Victor posted a link to P5JS. I would actually recommend that much more than 3JS. That was another one that I totally forgot the name of. That's a lot of the time for like graphs and stuff, but same thing. You're going to find a bunch of libraries that make the drawing a little bit easier. So you don't fully have to understand how it's drawing. You get an API to say what you want drawn, but you did hit on a point, which it is a mathematical thing. So you need to make sure that folks are comfortable enough working with that kind of math to be able to do that stuff. It can get complex. It can stay simple. It kind of really depends on what the game is that you end up deciding to make. Yep, thank you. I cannot recommend him enough. I've watched many of his streams, and he's wonderful. Actually haven't heard of the phaser library chat, but as mentioned, there are many out there, so I'm definitely sure you'd be able to find one. It'll end up kind of being dependent on what it is you want to make and how complex the drawing is for that. You know, if you're making, let me think, if you were going to make some kind of real-time strategy where you've got AI and you've got units and everything, and you need to coordinate where their positions are, that can start to get a little math heavy. But you know, if you're making a game like, let's say, Pokemon, the classic Pokemon game where you have these opponents battling, and really at the end of the day, all you have is a few potential attack options. You have a few potential item options you can use, or you can run away from the battle. The amount of math you would need to do or know in order to implement that is fairly minimal, because it's not really the rendering that's heavy on math. It ends up being the statistics and calculations for whether something hit, whether something missed, was it a critical hit, or all that kind of stuff. So heavily depends on the game you make.
Just got one more question I'd written down. You had mentioned that often, the cons of a language won't be immediately obvious. Do you have an example of like when you ran into a situation where you chose, a language to build something in, and you ran into something, you ran into one of those, some sort of gotcha or something somewhere, and then like, how did you deal with it when you did?
I've had many of those in my career, but I always don't think too hard on them. Well, one small example I can give, which was based in Node.js, so it was JavaScript. What the problem ended up being was that, we needed an application that was able to take in lots of input from users at the same time. And it was kind of queuing up what it needed to do, and so that it could complete it at its leisure anytime it wanted. And so on the surface, that seemed really straightforward that, well, I might have a huge burst of input from users. Maybe they're all playing at the same time. They don't need to necessarily see the results of their scores right that second. I have a little bit of time to process it. So sure, I'm going to use Node.js. I'm going to use a queuing library. I'm going to bundle that all up, and things will be wonderful. So what ended up happening that was specific to the language that I wasn't aware of at the time was how the Node.js event loop works. So to give a tiny, tiny short version of what the problem is that Node.js runs JavaScript code, and it supports asynchronous behavior. So for example, if I know that fetching data from some URL is going to take maybe a few seconds for me to get that, I can tell JavaScript, okay, this is a promise of some data that is being fetched, and I want you to kind of put that on hold because it's going to take some time for me to get that data. Meanwhile, while you're holding on that, I want you to do this other processing. So it's kind of a way of saying anytime a piece of code needs to wait for anything, let's work on some other code in the meantime, and then we'll transition back to that. So what I didn't know about the event loop of Node.js is that the order is not deterministic. So there's a way that you can say this promise has to run after that promise, but if they're not explicitly chained together, then you have no control over what's going to run when. And so what ended up happening was we had the situation of data races, because things that we didn't realize were being run randomly at random times was, a step 3 was running before a step 1, and so it would throw an error. And then step 1 and 2 would work successfully, but then step 4 would fail because step 3 failed. But its error wasn't really obvious because we just assumed that those steps would work in order correctly. So that was where some learning kind of came in about exactly the specifics of the Node.js event loop. And now that I'm aware of how it works, I can write my code to anticipate that and to be aware of it. I didn't technically change languages at that point, but we had to refactor a fair amount of code in order to be aware of that. One of the kind of neat things about Rust asynchronous code is that because it's this low-level compiled language, it doesn't have an event loop built in. So there is no built-in functionality for running code async, but instead they have a few preferred libraries that they say, oh, well, if you want them to run in this way across multiple threads, you can use this library. If you don't need multi-threading, then you can use this library, and so on. So you can kind of pick and choose the exact thing that you need. But that was a big annoying one that happened to me.
Yeah, that sounds really hairy.
And that was the thing where there was just no way to really understand what those consequences were going to be until we wrote the code. Anyone have any other questions? You're right. I'm sorry for missing that, TGG. So it will kind of depend on kind of what the comfort level of folks is. So TypeScript is extremely close to being JavaScript. It's technically its own language, even though there's tons and tons of overlap with JavaScript, and it kind of came out of wanting a TypeScript JavaScript, or I should say a type-safe JavaScript. But that introduces a lot of complexity. So one of the things that ends up happening is that with JavaScript, much like another language like PHP or Python, JavaScript, PHP, and Python more or less follow the practice of duck typing. And so if I create some object and I give it some set of properties, then all I really need to do is check that it has those properties and I know that it's the right type, so to speak. But with TypeScript, anytime I have a piece of data, I need to start defining it, just like defining a class when you're thinking of object-oriented programming. So if I'm going to have an object that gets returned on an endpoint, as an example, and it will always have a status field and maybe a result field. Okay, well, I have to make an interface type for that. So now TypeScript will always be aware of, okay, anytime they say it's that type, I know it must have those two fields. So the advantage is that now if ever you're missing one of those fields, it's going to throw an error immediately. It won't even let you run the application. But at the same time, that also forces you to slow down the development a little bit and take your time building out what are all these interfaces? What should the data look like? Now, I will mention that in my day-to-day job, that is basically my primary focus. I'm extremely in favor of type safety. I think that it's one of those things that slows you down early on in a project in order to save you from weird bugs that you'll spend so much time down the road trying to figure out what's going on. So ideally, you want things to break and fail as quickly as possible, because then you'll know it's a problem and you'll fix it early on. Once things are deployed, once things are in other people's hands, you can't easily do debugging. And so you kind of want to try to use tools that will catch that ahead of time. So TypeScript has that with some types. If you use a language like C, already kind of has that built in. Java already has that built in where it's got those type requirements. There are other tools you can technically use to sort of inject it into JavaScript, but it's not a good idea. They don't tend to work very well. And then, yeah, so it kind of depends on that learning curve or that extra amount of time for effort. If you want to, just like I talked about earlier, it being a good idea to have tests, it being a good idea to have documentation, types fall into one of those categories of this will absolutely improve the quality of your application and it'll make it last longer, but it takes time up front. So that'll be kind of a decision you'll have to make when making those decisions later of like, how much time do you have? Can you really do all these things? What's important? What can be dropped? I see a question in the chat. Do you have any resource or advice for students who might be looking at a JavaScript project like, I have never coded this language before, how can I possibly help? That's a good question. Usually, when meeting someone who's looking to get into JavaScript, I usually direct them to the MDN or Mozilla Developer Network documentation. So each kind of language is going to have some of its best basic resources, kind of like PHP has php.net, and still to this day, I think has some of the best documentation of any language on the planet. For JavaScript, the Mozilla Developer Network is fantastic. For Rust, they've got their Rust docs, which is also really detailed and good. It gets generated automatically from the code that you write, so that you don't even need to necessarily be writing out everything yourself. Same thing if you use JSDoc or JavaDoc or any of those tools. And so those resources I recommend. The other thing that's kind of nice about JavaScript is the ability to experiment with it easily. It probably would take not necessarily a large amount of mentorship, but maybe an opportunity to pair up. And so a couple people could kind of get together, someone who's a little familiar. But even if you open up a web browser, you open the inspection tools, and you go to the console, you could just start typing JavaScript and run it. So if you've got a piece of JavaScript, you can change the value of a variable. I'm very much a proponent of folks should be tinkering with the code to see how it works. That's at least how I've always learned. And then Node.js, which I highly recommend having installed, even if you're not really sure of what you're going to do. That is JavaScript on your computer or JavaScript in a server. Then you could just type Node in a terminal, hit enter, and now you've got an interactive terminal where you're able to just write some JavaScript code and have it execute. Kind of like you might see for those of you who have experience with Python. The same sort of thing. I can just type Python, hit enter, and now I'm in this interactive language shell where I can just write code to kind of see what's going on. There is one other resource that I want to link. Let me find the URL. This site here is one that I've been using to improve my skill in Rust lately. There's a ton of languages on there and tons of practice problems with mentors on there who will give you advice or talk about why your solution to a problem might be good or bad. Highly, highly recommend exorcism.io, which is linked in the chat. What else are we thinking? Well, if we have this much silence, that must mean that we're all ready to super confidently decide what language we want to work with next session, right? At the very least, around the time, when is that session where those kind of decisions are being made? Is that this Friday or a future week?
That is next Friday, June 11th at 7 p.m. right here in Foobar Voice. Yeah, we're changing it up a little bit because Andrew Holden gave us like a really good start with outlining, what is required at gathering and so on. And we had a chance to sort of grill Kevin Brown on the idea around this project. And now we sort of need to transform a lot of those questions and answers into job stories. And then we will be sort of running through it. Like Andrew Holden sent me a little follow-up. I posted all of this in the text channel here, but in case you didn't read it, next Friday we'll be doing a sort of like a little, hopefully a fun activity where we will collectively, we'll determine, we'll take what job stories are there and we'll say, hey, this 1 to 3 feel like the most important ones, that we want to address. And we will sort of brainstorm together different ideas that we can build to sort of address the outcomes in those stories. And by the end of that little session, we'll sort of have hopefully a solid idea of what it is we want to build. And then we can discuss, okay, now that we know what we want to build, how do we want to do it? Do we, and we'll know, we know now sort of our options, right? We know that generally it might either be JavaScript or Java or C# likely. And, on Friday, Jen, we're bringing you back to talk about how we might deploy it. And, with that knowledge, we'll have a discussion and a vote around, determining those details.
Sounds good. Cool. So yeah, that's good then. That sounds like a good plan to go through. And I think kind of like all these points that I mentioned, I'm sure I threw a ton of information out there today. I'm always kind of lurking around in this chat, so feel free to post questions in the channel. I'm happy to respond anytime. But try to keep those things in mind of like what the comfort level of people is, what kind of tools you think you might need to work with, or what those minimum kind of standards you want to have is. I think that'll be super important as you're going through those decisions. Before I get too sidetracked, I saw another question in the chat that I wanted to answer, which was about the practicality of a functional language like Haskell. Haskell is a language that we used for a while at Weever Apps. And I think one of the problems we ended up facing there, which if it's not a problem that ends up happening with your group, then that's fantastic. There's a lot of positives to using not only a functional, but a language that has a really powerful type system. The only 2 languages that I know that are super strict, have functional programming, and are really strict on types is Haskell and Rust. Rust isn't as strictly a functional programming language. It's kind of a little bit closer to C, C++, but it does have a number of those same features. So we had written some Haskell applications, and the thing we found that is because Haskell needs to kind of like mathematically make sense, the types need to be just right, everything needs to be laid out well, and has a very unusual syntax. You're going to see operators that look like a less than symbol, an asterisk, and then a greater than symbol, and that's how you would like map over a collection or something like that. So you have to be aware that the syntax is extremely unusual, and that kind of like we were talking about with TypeScript, it's going to be a very strict language. So if you have enough people who are comfortable or interested in learning that, then I definitely think it'd be a powerful tool to use. It does have a runtime, kind of like Java, or even C# to an extent. So it can't just run on its own. At least I might be mistaken on this. I don't think you compile it to an executable. I think you still need the Haskell toolchain. Kind of like if I was building a server-side JavaScript application, I would need Node.js to be the thing that actually runs the code. I can't compile to an executable. But yeah, having team members being able to work on it, I think, was our barrier. So we had one person who was a huge Haskell evangelist. I had learned some stuff from him and from my own research. I was starting to get okay with it. But then when he left the company, we were at a point where there weren't really many developers at Weever who were comfortable continuing to maintain it. And so we ended up having to rewrite it in Rust. So that ends up being the only thing of whether or not you can find the people interested in it. Super cool, but complex.
Cool. Yeah. Great questions, guys. Are there any more questions for Jen? Nope. Okay. So let's call it there. Nice and relatively short tonight. Thank you so much, Jen, for coming out and giving us sort of the lowdown and giving us like a lot of really great advice. I'm going to be posting some of the notes that I took tonight. I'm not a very great note taker, so I'm hoping that some of the rest of you will also post your notes if you took any as well, and maybe we can sort of like crowdsource it. We will also be posting the video recording of this up online on our YouTube and sharing that in the text channel as soon as that's live. Thank you, Victor, so much for recording that for us. And then, yeah, we'll be meeting back up here on Friday at 7 p.m., where Jen will be introducing us to how do we deploy an application.